My name is Ben Palmer, and this is my project for week 9. I decided to again keep it as simple as I could just to make sure I understood the code, and I did a thumbtack. So it's basically the example that we had in class, but with a larger head to resemble more of a thumbtack. So for this shape, I kept the Cauchy stress the exact same. So that's the 2 times x1, 2 times x2, and then the 2 times x3, and then you got the x1 plus x2, x1 plus x3, and so on. So this is the same, and then I kept the scale and the magnification the same as well. So here's the body. I wanted to focus more on body 1 because that's the one that needed to be spread out to look more and resemble more of a thumbtack shape. So to do that, it was for the parameterization, I multiplied the x1 and the x2 by 6, and then carried that down here to the Jacobian as well as down here. And then for b, I actually had to make that 24, 24, and 24 because the result for that would have been 4. The divergence of S, so that's the divergence of the Cauchy stress, so that would have been 4 for each one, but when it's multiplied by 6 you get 24. So let's move on to, this is what we were trying to solve for by hand. This is the result I got for body part 1. The total force acting on it was negative 301 in the x1, x2, and x3 directions. And then here's the shape that I was trying to make. So as you can see, it's spread out on top, so it resembles a thumbtack with the shaft down here. And then here is the hand calculation check for that. So my parameterization or parameterized equations for body 1 are here. It's just 6r cosine theta and 6r sine theta and z. And then the divergence of S for x1, x2, and x3 were 24, 24, and 24. So you want to take the triple integral of that times r with respect to d theta, dr, dz. So for the first integral, the negative 24r, you end up with the negative 24r 2 pi. And then the second integral, it's 0 to 2. And you get 24 pi 4, or 96 pi. And then the third integral with respect to dz, or with respect to z, is 20 to 21. So it's that 96 times pi times z from 20 to 21, and you get negative 3001.6. It's hard to see, but that's what it says right there. It's negative negative 301.6. And you can multiply that by x1, x2, and x3 because it's the same in all directions. And that resembles what we got here from the MATLAB output. But that's all I have. Thank you so much.